All right, working in section 5.4, I'm going to specifically look at some special things about working with integrals. We're going to start off by thinking about an even function. And specifically, let me see if I can move this. There we go. Oops, there we go. Okay. There we go. All right, specifically, I want to think about a definite integral from negative a to positive a for this function f of x. Now we have a function and I've started with a really simple even function y equal x squared. And if we look at this function, remember that the definite integral is the net area or signed area under the curve. So if I'm looking at an integral from negative a to positive a, I'm looking at area under the curve. Oops, that's an a right there. Or the area of that shaded region. Now what you notice there, I hope, is that the two pieces of area there are exactly the same shape and size. So we can say that a definite integral from negative a to positive a could be rewritten as 2 times the integral from 0 to a of f of x dx, which simplifies the integral that you have to work with just a little bit. Next, taking a look at an odd function. Remember that odd functions have symmetry in the origin. So again, I'm looking at a very simple odd function, y equal x cubed. And if we are considering the definite integral from negative a to positive a for this odd function, then maybe that's negative a, that's positive a, then that definite integral represents the area of this region that I've just shaded in red. Again, the two pieces of area there are exactly the same shape and size. The difference is one is above the x-axis and the other is below the x-axis. Since a definite integral gives you signed or net area, then we've got a negative area for this space and a positive area for that space. The negative plus the positive, because they have the same value, the same size there, is always going to be equal to 0. So if you have an odd function and a definite integral you're supposed to calculate from negative 4 to positive 4, for instance, you don't have to do any work and you're going to know that that net area is going to be 0. Now, to show you an example where you might use that, let's say I have an integral from negative pi over 2 to positive pi over 2 of the function cosine of x minus 4 times sine cubed of x dx. Now we split that up into smaller pieces because that's easier to work with. Looking at a definite integral for cosine of x dx minus 4 times the definite integral of sine cubed x dx. Okay, cosine is an even function. So our first integral we can rewrite as 2 times the integral from 0 to pi over 2 of cosine of x dx. And then sine is an odd function, and if you've got sine cubed, that's also an odd function, so our second definite integral is going to have a value of 0, which simplifies our life just a whole lot. So then all we have to deal with is taking the antiderivative of cosine of x, which would be sine of x, evaluating that from 0 to pi over 2, and multiplying by 2.